Hello my dear friends, welcome back. Let's continue with permutations and combinations. So if you've watched the previous two videos, there we have learned many things about factorials, very important, okay, factorials, and also even the fundamental principles of counting, the addition principle, the multiplication principle, and means multiplication or means addition. Right, we have learned, so those two concepts are going to be very important. So if you have gone through that, then definitely permutation and combinations will not be a big problem for you. Yes, as I always say, imagination would be required. And if you still haven't gone through those videos, I will be providing you the link below. You can click on the link and watch through those video tutorials, and then again come back and continue with this particular video. Now let's head back to permutations and combinations, which is going to be very brief and interesting also. Now, let us just assume that I've given you three letters, and what I'm telling you is you take two letters at a time and make as many arrangements as you can. Okay, got it? I've given you three letters A, B, and C. Take two letters at a time only and make the number of arrangements as many as you can. So let's try. A, B, B, A, two at a time. So A, B, B, A, C, C, A, B, C, C, B. I believe you have your pen and paper with you, and then of course I believe you're doing. That's the way to do maths. You don't do maths by watching. Okay. So I think that's it, isn't it? So I don't think we can have more than that. Yeah. So we have actually like using these three letters by taking two at a time. We have how many arrangements? 1, 2, 3, 4, 5, 6. Fine. Now if I say you do it by taking three at a time. Now let's try by taking three at a time. So let's see. A, B, C. A, B, C. A, C, B. Right. A, B, C, A, C, B. B, A, C. Isn't it? A, B, C. A, B, C, A, C, B. B, A, C. B, C, A. Think. Make more combinations. B, C, A again. B, C, A, C, A, B, I guess. C, A, B and C, B, A. I think that will be enough, I guess. So here also we have like 6 arrangements that we can possibly have. So that's what permutation is all about. Nothing else. Permutation is like there will be certain objects given to you, numbers, letters, and they will tell you, okay, you make the arrangements by taking 2 at a time, 4 at a time, 3 at a time, 1 at a time. That's what permutation is all about. It's about arrangement. How many arrangements can you make? How many arrangements, in how many ways can you make the particular arrangement? That's permutation for you. Now how is it different? So in other words, permutation is more about permutation. These are called permutation, okay, not permutation. These are called permutation. Each arrangement, this actually permutation in other words is called arrangement. ARRANGEMENT. This permutation, the other name for permutation, the way you can remember, is known as arrangement. Alright, arrangement. Now each arrangement is called a permutation. PERMUTATION. Each arrangement is called a permutation, and the number of arrangements that we have are called permutations. Alright, singular, the group, permutations. Permutation, each arrangement. The group, number of arrangements are called permutations, arrangements. Alright, just some grammatical word. Now that's what permutation is all about, arrangement. Right, so by taking, we have 3 objects. How many arrangements can you make by taking 2 at a time? Now the question is, how is it written? No? How is it different from combinations? Here itself, let's find out the difference between permutation and combination. Now the question is, how is it different from combination? This was what? Arrangement. ARRANGEMENT. Now listen closely. Now again I'm telling you, the same 3 letters are given to you. Take 2 at a time. In how many ways can selection be done? Selection. In how many ways can selection be done? Selection. The other name for combination is selection. That's how we can find out the difference. Now selection means, in other words, let me tell you another thing, that is like in permutation the order of arrangement also matters. Okay, the order of arrangement is also important, but in combination, selection, arrangement, selection. In combinations, the order of arrangement does not really matter. It's just about selection. Are you selected or not? How are you selected? That's not a concern. Arrangement is not a concern here. It's, are you selected or not? Like some examples, will be like, maybe in a running race. In a running race, there are some participants running together. So now, who gets the first prize, the second, the first runners up, the second runners up? This will be considered as arrangement, because when I am running with my friend in a running race and all, me getting the first champion or me getting first runners up are all very different. I can be placed in first, that's different. Second, that's also different arrangement. Third, that is also a different arrangement, or no prize, especially I'm not a very good runner. So no prize. So these are called arrangements. No, let's say in a library, the way the books are kept. So that is also an arrangement, the way the books are kept, in how many ways can we keep the books. These are examples of permutations. Now, combinations will be about selection. Like we have a football coaching camp, and then like in how many ways can you be selected? You can be selected in just like maybe like, it's all about how are you selected. Now, are you selected or not? It doesn't really matter whether you are selected in the first or in the last. You're still selected in the team, isn't it? But you get first in the running race and you get last in the running race, very, very different. This is permutation. But whether you're selected first in the team to play football, in the team of football, or you're selected last in the football, 11 players, the first 11 players, selection of the 11 players, doesn't really matter whether you're selected first or the 11th selection. It's just about selection, isn't it? So we're always happy the moment we're selected. It really doesn't matter when I am selected. But when you're in a competition, it does matter. Individual competition, this matters. So that's like the way we arrange books, different colored books that we can arrange. Yeah, these are examples of permutations. Combinations. So see that, imagine, as I told you before also, that imagination is very, very important in this particular. That's why it's used so much in all competitive examinations. Because here every day a new question can arise. And that's how it goes. So that's why, and very practical question, very practical. So we can just, the question setter can just confuse you with day-to-day problems, and they will leave it to you to sort out whether it's an arrangement problem or selection problem. So a lot will depend on you to identify also arrangement, imagination. You have to feel that question. Okay, you have to feel that question, and selection. Okay. Now the question is, in how many ways can I select the letters? By taking two at a time. Now A, B, B, A doesn't really matter, because in this A is selected, B is also selected. Here also A selected, B selected. So any one I will take. AC, CA. Here also one I'll take. BC or CB. It's just about selection. So here also B selected, C selected. Here also B selected, C selected. So now combination, of course, we have only three combinations. That's called selection. Similarly, if you take three at a time, that's only one, because here also ABC selected, here also, here also, here also, here also, here also. So it really doesn't matter how is it selected. It's selected or not, yes. So in combination we have only one selection, that is ABC. So that is the difference between combination and selection. Always do remember that. Permutation, arrangement, combination, selection. Correct. Okay. Alright then, now let's learn more about permutations. So you can just write down permutations. You can write down the different arrangement, the different arrangements which can be made, the different arrangements which can be made, the different arrangements which can be made out of a given number, which can be made out a given number, which can be made out of a given number of things, by taking some, or all, by taking some or all at a time, by taking some or all at a time are called permutations, are called permutations. So notation, how do we notation? How do we denote with notation? Like, you can just write down, let's say, like, let R and N, the general letters that we generally use. Let R and N be positive integers. Be positive integers such that, let R and N be positive integers such that R is greater than or equal to 1 but less than or equal to N. I'll come back to this point very soon. Then the number of all permutations, arrangements or permutations, then the number of all permutations of n things taken R at a time is denoted by NPR. These are all exponents, index exponents, okay? N on top, PR. Number of permutation of n things by taking R at a time. It is also generally denoted as P and R. We use this more. Okay, so NP written, I am going to rub this off. So the number of ways of arranging n things by taking R at a time is denoted by NPR or Pn of R. Now this value, that is NPR, what is it? Number of arrangement of n objects or things by taking R at a time is given by n factorial divided by n minus R factorial. That's why I had to teach you about factorials first. About 0 factorial, you can just check that video. I'll provide you the link below also. Why is 0 factorial 1? Okay. So NPR factorial is generally given by n factorial upon divided by n minus R factorial. That's the formula that is given to us. The number of arrangements of n things, n dissimilar things taken R at a time. Okay. Now, why is this condition given? Now this condition, R should always be greater than or equal to 1 and it should always be less than 1, because you see, again, practical concept. The number of things that is given to you should always be greater or equal to the number of groupings or objects that you can take. Now, for example, like if you have 10 benches, I can only tell you that, okay, you have 10 benches, take 3 at a time and arrange them. In how many ways can you make the arrangement? Isn't it? Maybe I have 11 balls. I can tell you, okay, you have 11 balls, you make them into groups by taking 5 groups of 5 at a time. Now these are all practical questions, but now think. You have 10 benches. Now what if I tell you, okay, you have 10 benches, how many arrangements can we make by taking 0 bench at a time? Now, we're taking 0 benches at a time. How is that possible? That is not possible. That's why R should always be minimum. But 1 bench at a time, that's okay, because in that case we can have 10 separate arrangements. No problem with that. But 0, we can, how can we arrange no objects? So that's why r should always be greater than or at least equal to 1. And another concept is you have 11 balls, 11 bags, let's say. You have 11 bags, arrange them. How many arrangements can you make by taking 20 bags at a time? Now you see the problem is I have only 11 bags. How am I supposed to find out the number of arrangements by taking 20 bags at a time when I have only 11 bags? Not practical at all. That's why the value of r at the most can be equal to n or less than n. Keep that in mind, okay? Alright. So that is what permutation is all about. And then of course you can write another formula. Please quickly write it down. The number of all permutations, important. The number of all permutations. The number of all permutations of n different. The number of all permutations of n different things of n different things taken all at a time. Taken all at a time. Taken all at a time is given by NBN, and that is n factorial. Okay, so that is one theorem which will come in handy when we start solving mathematics. Now let's solve some examples. Let's solve some examples. Like the first question, let's try to solve 75p2. Please write it properly, okay? Don't write like this, 75p2. That's not the way we write this. Exponents, or just in terms of smaller letters, 75p2. Let's use the formula. 75 factorial divided by 75 minus 2 factorial. Because what was the formula? It was n factorial divided by n minus r factorial. And that's why I did this factorial, because it's important. So that will be 75 factorial divided by 73 factorial. So that will be 75 into 74 into 73. I'll stop there. Divided by 73 factorial, cross. So what will be 75 into 74? That of course you can calculate for yourself and check. That will be 550. 5550. So yeah, these are our mathematical problems. So here of course you should not face much problems. Let's see number 2, 8p8. That will be 8 factorial n minus r factorial. Because what is n? 8. What is r? 8. So it's going to be 8 factorial by 0 factorial. We have already seen that 0 factorial is 1. So that will be 8 factorial. And that verifies the formula which I gave you just a few moments ago. And why is 0 factorial 1? I'll provide you the link. You can check a very interesting video on why is 0 factorial 1. Okay? Alright, now let's solve another question, that is another example, that is if NP4 is equal to 20 into NP2, then the question is find n. Let's simplify. NP4, let's expand on this side. N factorial, n minus 4 factorial. This will be 20 into NP2, n factorial, n minus 2 factorial. So n factorial, common 1, 1. 1 divided by n minus 4, I will let it be 20 by n minus 2. N minus 2, next n minus 3, next n minus 4 factorial. We have already learned factorials, so I believe I don't have to explain that to you again. But still then, when I say, if you remember, 4 factorial, 6 factorial. Now, which of these factorials should I expand to get to the other factorial? We should always expand the bigger factorial, definitely, to get to the smaller factorial. Now, which of these, see, if I expand 4 factorial, I am not getting anywhere near 6. But if I expand 6 factorial, definitely on the way I will meet 4 factorial, where I can say hi, hello, have a cup of tea together, and then carry on, isn't it? Because 6 factorial is 6, 5, 4, 3, 2, 1. So that's where I meet 4 factorial. So here n minus 4, n minus 2 is bigger. Definitely n minus 2 is bigger because less is subtracted. So I expand this, 1 less, 1 less, 1 less, 2, 3, 4. And because of that, n minus 4, out. Practice, practice, practice. Okay, NCERT textbooks, very good textbooks, but I don't prefer because especially for practice, not enough. Good. We all have our different opinions. It is good. I'm not saying that the textbook is bad, but for practice, you need more textbooks. Other textbooks, reference textbooks, guide books and all. Okay, you will need different textbooks. If you want to be good, if you want to be good in mathematics. Now here, of course, I did not show you, this is already in class 11, so I believe you understand multiplying and solving. So you will have n square minus 5n minus 14. So factorizing this, n square 7 to the 14, 7n plus n minus 7 plus 2 n minus 7 n minus 7 n plus 2. Either n minus 7 equal to 0, n equal to 7, or n plus 2 equal to 0, n equal to minus 2. But we know that n minus 2 is not possible. You know why? Why n minus 2 is not possible? Well, that's what we were saying. You remember that condition, no? Because n should be always greater than or equal to r, and r should also be always greater than or equal to 1. Mathematically, logically, number of objects can never be negative or can never be fractions. How can I have minus 2 tables? Possible or what? No chance. Minus 2 tables, not possible. Minus 3 tables, not possible. How can I have half table? Is it possible? Half table, half human? No, that's not possible. So when we talk of objects, we don't talk in fractions, we talk in integers, positive integer terms only, okay, positive integer terms. So that's why the value of n will be, of course, 7. Minus 2 will not be possible, so minus 2 will be just simply ignored. Okay, alright, now again, let's continue, maybe. Okay, let's see. Another question. That is proof that NPN, this can be even used as like small theorems or shortcut tricks, especially for JEE examinations or MCQ examinations. So NPN, let's prove that it is also equal to NPN minus 1. So let's prove. Let's see LHS. What is NPN? N factorial by n minus n factorial. Now NPR, r value is just n here. These are just models. So NPR is n factorial by n minus r. But unfortunately, what is our value of r? It is also n. So n factorial by 0 factorial. So n factorial by 1, that is n factorial. Let's try to solve RHS right hand side. Okay, I'll just write npn minus 1. So that's n factorial divided by n minus r. What is the value of r? This is the place where generally most students make mistakes. NPR is n factorial by n minus r. Minus r. What is the value of r? Don't do this stupid mistakes, okay? Minus means bracket because the r term is n minus 1. So it's really going to change. So n factorial by n minus n plus 1 factorial, n cancel, you have n factorial by 1 factorial. That's n factorial by 1. So that is n factorial. So LHS equal to RHS, hence proved. Hence proved. Okay, so yeah, that is what permutation is for you. So yeah, I hope you got a feel of what is permutation, isn't it? How do we use permutation, and also it's not a very big deal. Anyway, can we solve one more question if you don't mind? Let's try this. 5PR. If 5PR is equal to 2 into 6PR minus 1, then the question is find R. Last question. Then the question is find the value of R. Let's solve. Find the value of R. If 5PR is equal to twice of 6 into P power R minus PR minus 1, find R. Let's solve. 5 factorial, 5 minus R factorial, 2 into 6 factorial, 6 minus R factorial. Now, just now I reminded you about this negative value. NPR, n minus R. What is R? R minus 1. I hope that is clear, isn't it? So 5 factorial, this one also let be 5 minus R factorial. 2 into, now 6 factorial, I think I can write 6 into 5 factorial, no problem, isn't it? 6 minus R plus 1 factorial. 6 minus R minus plus 1 factorial. Now 5 factorial, 1, 5 factorial, 1, I can cancel, so that's like 1 by 5 push minus R factorial equal to 2, 6 are 12 by 6, 7 minus R factorial. Not yet solved. Okay? So, chalo. 1 by, which one is bigger? 12. This is bigger, so I'll expand this. 7 minus R. Next will be 7 minus R minus 1. Next will be 7 minus R minus 2 factorial. I mean, if we just follow the procedure. Otherwise, you can write directly also. 7 minus R. Right, you can write directly also. That is, it should be 7 minus R. Next will be 6. Come on, man. Alright. 6 minus R, next will be 5 minus R factorial. So 5 minus R, 5 minus R. Gone. So now, factorization. So that's 7 minus R, 6 minus R is equal to 12. 7, 6 are 42 minus 7R minus 6R plus R square minus 12 equal to 0. So that's going to be R square minus 13R plus 30 is equal to 0. And that's going to be R square minus 10R minus 3R plus 30 is equal to 0. R minus 10 minus 3, R minus 10 equal to 0. R minus 10, R minus 3 equal to 0. That implies R is equal to 10 or R is equal to 3. I'm just skipping a particular step here. Okay, if you, only for this problem, I'll just write again. But I think we can avoid all these useless steps because you are in class 11 now. I think that's all clear. 10 minus, so minus taken common, 3R minus 3R plus 3 tens are 30, isn't it? R minus 10 minus 3R minus plus 3 tens are 30. That's fine, no careless mistakes, I guess. I'm also human, I also make mistakes. So now, that's it. But The problem is, what is going to be our value of r here? Is it going to be 10 or is it going to be 3? Or both or none? See, what were our questions? Our questions were 5PR regarding the permutation, 2 into 6PR minus 1. Now if you remember, we have studied that the value of r can never be greater than n. The value of r can never be greater than n. What is the value of n here? 5 or maximum 6. Now this 10 we cannot use, because 10 minus 1, this will become 6p9 if I use 10. This will become 5p10. Now this is becoming bigger than this. That is not possible. I've already told you why it's not possible. So since r should always be less than or equal to n, r will be equal to 3, because our condition was 1 r less than or equal to n. And that's why our value will be, of course, 3. Okay, so mathematical way of solving permutation is this. So this one is not very difficult, but yes, once the exercise starts, we have more of practical problems, word problems, imagining, feeling the question and all. So that of course we will do. I think this is enough practice for you, at least for now. Next, we'll do in the next video, that is going to be, we'll be straight jump into the exercise, that's with the practical questions. That is exercise 7.2, I guess. Yes, 7.1, 2, 3 or 2, the next exercise. Okay, alright then, till then, take care, stay safe, see you soon.